just started it. So we're good.
All right, great. And tonight we're going to be talking about one of the, if not the most funnest subjects, schedules. Now, the exam has changed so much from over the last 2 years. Uh, and we'll go into some of those pieces too. But we've got a couple of different things we're going to be looking at for predictive and for adaptive. So for predictive, the project manager has a lot of responsibility and a lot of things to do. So the PM needs to ensure that the work package is broken down into required activities. So that's really creating all of the required activities for the entire project. And if we're talking about a 16, 18-month project, that can be hundreds of required activities. So generally, PM will pull in some help to get that done. Ideally, some people who've got some experience with that. Okay, so again, dependencies and precedents, relationships, and we'll talk about those in a little bit. Determining those, durations, critical path. Uh, that's going to be a lot of fun. We'll hit that too. And resource allocations, either over allocation or under allocation of resources. That's includes human resources, lab equipment, cranes, bulldozers, rock crushers, you name it. Anything that's required to complete the project. And try and make sure that the schedule is compressed to meet any constraints. You know, just getting out the whips and chains and uh, urging people on to meet the deadlines. Now, it's slightly different with an adaptive project. Um, can anybody tell me what the continuous flow, another name for continuous flow method is?
Like Kanban?
That's it. Yep. That's where you the team takes on tasks from the backlog and works those all the way from start to finish, but it's not on a cadence. All right, so we have time box methods such as Scrum that are going to be developing and delivering on a cadence. And generally the cadence we use is about 2 weeks. Now, overall, we can also plan in adaptive projects for when we're going to be releasing things to the customer. Okay. And the project team, not the project manager, plans each iteration of work that they're going to be delivering. Okay. So generally, if you're using Scrum, the product owner is going to prioritize the what is going to be done, what the prioritizes the backlog so that the proper uh, components are delivered in each of the iterations. Now, the team members are responsible for estimates, and the team and the product owner work together to decompose the user stories into tasks. and determining what the iteration velocity can be. The Scrum Master is also involved with that. Okay. So after each iteration, so we're talking after each 2 weeks, the whole team will go through and refine the backlog. The product owner is responsible for the prioritization, and the team helps whenever possible with the estimates for completing each of the items in the backlog. All right. Schedule management plan, as you can see here, remember this, that it is for predictive projects. All right. Components, description of how activities are going to be defined and progressively elaborated. It identifies some basic things like the scheduling method that's going to be used and scheduling tool, whether it's something as basic as Microsoft Project or something as complex as Primavera or other network-based tools. Schedule formats also documented in the schedule management plan, and it establishes the criteria for developing and controlling the schedule. Okay. So this is a document, again, that if the project manager either wins the lottery or gets hit by the bus, that the next person in line can pick it up and run with it. All right. Management plan can be tailored for use in any type of project, not necessarily just predictive. Um, hybrid approaches can also take advantage of a schedule management plan. Let's pull up the definition. So if you want to take a screenshot, and realize for predictive projects, schedule management plan is a component of the project or program management plan. Okay. A lot of components to the schedule management plan. The model that's going to be used to develop the schedule and maintain the schedule, including what tool is going to be used, if any, or including things as basic as Excel spreadsheets. Excuse me. Any planning for maintenance, including status updates and progress during execution. Okay. Accuracy is really a documentation of the accuracy that's expected for each of the estimates and the deliveries. Okay, so that I know in predictive projects, the accuracy can vary all the way from, say, plus minus 25% in the early phases, and then the accuracy tightens up in the later phases so that it's usually at a maximum plus or minus 10%. But again, those are all estimates. Uh, there's the human factor in there, and we don't always hit that accuracy. Yeah. Just some stuff, the list, defining each resource, unit of measure for each resource, like staff hours, days, weeks, pounds, tons, whatever. Okay. Um, any of the organizational procedural links, this relates back to the use of the WBS, which is an acronym for what?
Work breakdown structure.
Yep, thanks. To ensure consistency with estimates and schedules. Okay, you want to have traceability from the components that you have developed for the work breakdown structure, and be able to trace that back through everything. What's meant by control thresholds, where it's another one of the envelopes where if you're within the envelope, you are able to take actions, perhaps even spend money if necessary, on the project in order to keep it in line. Outside of the envelope that's defined here, you'll need to go through either a change control board or work directly with one or more key stakeholders. And then rules, reporting, and process descriptions. Okay. For predictive projects, the rules they mention here, like earned value management, how you're going to determine the value that's been earned at each point in time. That, along with reporting, is, what do you do with that information? Who needs to know about it? When do they need it to know about it? What format do they need to have it presented in? Okay. And then process descriptions, it's straightforward there. All right, so when you're beginning a project, don't hesitate to steal things from other projects, information, schedules, things like that, especially from very similar projects. If you're in the construction industry and you're going to be building uh, just a one-story warehouse using pre-stressed concrete panels, and the company that you're working for has done that many times over, you should have good documentation and some good estimates as to where you can start, what the project's going to entail. So benchmarking is comparing anything to an industry standard or the best information that you have at that time. So if you have a history of projects, benchmarking can be used against those projects, and also if it's something perhaps brand new for the organization, against industry standards. Okay. Now, we'll get into this a little bit later here. The estimates, unfortunately, on especially on a predictive project, are done at times before all of the information is known. So before you get into detailed analysis, you can use some similar projects to give a wet-fingered guess as to how long it's going to take, what resources are going to be necessary, and what the how whether or not you feel that you can deliver in the time frame required. All right. Yeah. Alan, if I keel over, you're up.
I'll be ready.
All right.
You're a trooper.
Yep. Hybrid schedules. Okay. So let's talk about some of the characteristics and benefits of hybrid schedules. Now, for hybrid projects, you may have an outline of a plan that whenever you using adaptive methods, you're going to be elaborating on those plans every iteration, so that you're going to be taking a lot of feedback in, and in most cases, if not all, you're going to be doing more planning than if it were a predictive project. Okay. Now, some ways that can be done. The third bullet there indicates one of the ways where you could divide the product delivery into subsets according to a plan, either milestone that you have to hit, such as for a new product, say a show that you've committed to demonstrate the product at, or just based on cadence. All right. There's going to be a whole bunch of definitions here for predictive schedule planning. Okay. So as project manager, as we talked about, you got a lot of work to do. Breaking down a work package into required activities, determining the dependencies and the precedence relationships. And we're going to get into a lot more about precedence relationships in some subsequent slides here. Okay. You're going to have to estimate the duration of activities based on whatever you can find. History, determine how many resources you have, how many you need, and go back to the key stakeholders and let them know what the duration has to be, and then they'll tell you to pull in the date. But we won't get into that. You also have to determine the critical path. And as I said, we'll get into all those fun things in some subsequent slides. If there are resource over allocations, come on back. Come on back, little buddy. You know, if you've got one crane and you've got two places where you have to use it, perhaps you can rent a crane or sequence the activities in order to take advantage of when the crane's needed at various places. Okay. And also compressing the schedule. I don't know how many projects we try to compress schedules on, and even if we had to make critical dates, they were usually very aggressive, and you know, you have to be aware that if you're compressing the schedule, it may be something that is not going to be able to be followed necessarily. And you can only have people working so much overtime. You can only have people doing so many tasks at once. And if you want to grab a screenshot, here are the definitions. Okay. So the project manager and predict projects also going to be breaking down project activities. And this is, unless you've got, oh, let's put it this way. If it's a new effort that you're doing, and especially I've seen this issue in software development. You know, you do your best to put together the work packages. You do your best to put together the work breakdown structure and do your code of account. Did you see here? The project is at the highest level. Then you have what's known as a control account, which puts everything together so that you're able to give management information that they need or think they need at any time. And then you further break it down into planning packages for larger efforts. And then you will have a boatload of work packages on a large project. Okay. But good thing to know. That's what they show here. Tailor the amount of detail in activities to the project context to enable meaningful estimation and planning. Meaning, you know, you may need to get into more detail if it's a new project, new type of project that you're working on or putting together, as opposed to something that is really a copy of a project that's been done before by the organization. Okay. And based on history and everything, you can determine how much detail you're going to need. If it's another building, another building that is basically the same as hundreds or multiple ones that the organization has done before, you may not need as much detail as you would if you're developing something for the first time. Okay. Can anybody, can I get somebody to expand on that? Why do you think that might be the case?
Don't have any lessons learned or anything.
Yeah, yeah. There's definitely more uncertainty the first time through. So it's something that you do the best. Always do the best that you know of at that point in time and learn from that. Whether it's a single time that you evaluate everything at the end of the project, or whether you're doing, my brain left me, retrospectives after each iteration. Yeah. We have a definition of an activity list here. So you're going to have, the activity list is just a list of all the activities that are required to produce the value from this project. Okay. So it's something that you can check off when things have been accomplished. You can go back and reevaluate to see if something that was in there could have been eliminated, or if you would have needed additional activities listed. Especially helpful on first time projects. This should be basically carbon copy if your organization has done projects like this before. Okay, we have some dependencies that we're probably going to have to consider. We break them up into 4 buckets: mandatory, discretionary, external, and internal dependencies. Okay. Any mandatory dependencies, like having to get permits, things like that, from some a government entity. Yeah, you got to schedule it. You need to have everything like that in line first, before you can start any work. Otherwise, they'll shut you down. Discretionaries are the ones that are really a best practice in the industry. You may be able to modify that somewhat if you understand what the dependencies are and exactly what the project, how the project needs to deliver. Okay. It's and that may require external resources to help you determine if you can actually tailor the that type of dependency. Externals are exactly that. There are dependencies on activities performed outside the team's work. If you need something delivered from an external company, that's, you do your best to schedule that. But the project manager has limited or no control over that. All right. Now, just the opposite for internal dependencies, project manager does have control over those. Okay. All right. We're getting into the really fun stuff now with precedence relationships. What you will see if you do a precedence, use the precedence diagramming method, that you will have a list of activities or deliverables. You'll show those on a diagram where there is something that drives another task or work. Okay. Notice that precedence indicates which activity drives the relationship. In this case, the blue box drives the red box. You don't start the red box until you finish the blue box, which shows right here. Okay. And the predecessor, you work to complete the predecessor usually earlier in time than the successor. There are other, if you've got relationships there, you'll see it later. But if something just seems turned around, you can reorganize and flip the dependencies. Okay. And let's take a look at precedence diagramming method. Okay. All right. These are types of precedence. Finish to start, which is usually the way that you'll see these, especially when you're doing a network diagram, where an activity, in this case, activity E, requires activity A to finish before it can start. So activity A is obtain occupancy permit from Oasis Town Building Department. And E is identify finished spaces for the tour. Okay. So if you're going to be bringing people into a building, you better have an occupancy permit, or the liability is so high it isn't funny. Another relationship is finish to finish. In this case, it's activity D, where we're talking about completing the landscape and decorations that finish at the same time that the Finished spaces are identified for the tour. You can also have start to start, where two activities can start at the same time. So confirm key stakeholder and customer attendance. And activity F is erect signage with customer branding. Okay. You may have a lag in here on a start to start like this, where it may take a little bit of time in order to confirm all the key stakeholders and customers who are going to be attending. Okay, but you can, in this case, you can start putting up the signage for that for the tour, and then start to finish. Activity F is erect signage with customer branding, and that needs to, in this case, it would need to finish by the time that activity D, or complete the landscaping and decoration, starts. Okay. Any questions on these? On these types of relationships? Okay. Sometimes you're going to see where you have a lag or a lead time. Okay. For activities where in this case on a finish to start, there may be something that requires you to take an extra amount of time. For example, if you've got if you're building a road and you've got concrete pillars that you're building for that, where they're going to be load bearing, they're going to be carrying the weight of the road, you know, you can't put down the the actual road on the pillars until this concrete is cured. So it may take days, may take weeks, a number of weeks to do that. Okay. Leads and lags do not have a value, so don't include them in duration estimates. Okay, if you're estimating when things are going to be done, you don't include the lead or the lag value. All right. So start to start also, you can have something that a task or activity that can only start after a delay to get a previous activity going first. And this is the confirmed key stakeholder and customer attendance and erecting the signage. Okay. You may have a lag in here. To make sure that you have the right customers are going to be there, the right stakeholders. All right. Predictive. Activity duration estimates. All right. But all right, they have a formal definition here. A quantitative assessment of the likely number of time periods required to complete an activity. Or in other words, how long is it going to take to get this activity done? Okay. That is an estimate. It may be in staff weeks based on a calendar that is a Monday through Friday calendar. It may be if you've got the constraints, it may be just calendar days. And if overtime is going to be required. Now, the elapsed time can be the same as the activity duration estimate if you're working 7 days a week. Otherwise, the elapsed time is the actual calendar time required for an activity from start to finish. So say you're working 5 days a week, it's going to take two work weeks to accomplish it. So you've got 5 days 1 week, 5 days another week, 2 days, 2 calendar days in between those 2 weeks. So it's 10, 12 days. Okay. While your duration would be 10 days. All right. And then effort is the number of labor units required to complete scheduled activity or a work breakdown structure component. So you may have a duration estimate of 2 weeks, okay, 2 5-day weeks, but it's going to take you 10 people each of those 2 weeks to accomplish or to deliver the value. Okay. So the effort is going to be, you'll see staff weeks used a lot. Okay. So it would be 2 calendar weeks times 10 staff or 20 staff weeks. It's the overall effort to deliver what needs to be delivered for that particular activity. Questions on that?
Can you go back 3 slides to where you had like all the different types?
We can try. Is this the one?
Yeah, this is it.
Okay. Question on this?
I just want to get a screenshot of it.
Oh, okay. I take it some people have not received the student bundle yet. All right. Different ways to estimate. We have analogous, parametric, 3-point, and bottom up. Okay. Analogous means you're comparing it to something else that's been accomplished. It's a good wet-fingered guess. If you've built a mile of road before, if you have to build a mile of road today, and it's over this approximately same terrain and everything like that, you can really get a pretty accurate estimate of how long it's going to take just from that historic data. Okay. Now, if the historic data isn't 100% accurate, that's going to be, that could skew and your estimates. Okay. Parametric uses an algorithm to calculate the duration or cost based on historical data and project parameters. All right. You're using a tool to determine what the duration is going to be for the project, how many resources are going to be required, things like that. Okay. So if you've got information, say for building 1 mile of road, and you've got a project that requires 10 miles of road to be delivered. Okay. You can extrapolate from the single one that's in the historic register and get some good estimates um, for what your project is. So downside of that, it parametric estimates don't account for a learning curve. Okay, so that if you've got a new crew that's putting in a mile of road, that's, if you have to build 12 miles or 10 miles, they should be able to work faster and produce those extra miles of road in less time than it would take to produce 1 mile and 1 mile and 1 mile and 1 mile. Okay. We're going to get into 3-point a little bit later. It takes a look at what's most likely, what's optimistic and pessimistic, and averages them out to give you an idea, okay, of how experts or authorities would estimate this. You do need either some people with experience to do this, the 3-point, or if you've got you don't have if you don't have that available, these are your best wet fingered guess, your what your most likely wet fingered guess, and your pessimistic. Okay.
Would that be like pros and cons sheet, sort of?
Actually, what you'll do is you'll take, say you got a panel of 3 people to have done this type of work before. You'll take, well, how long do you figure that this project will take? Okay, what's if everything falls into place, how long would it take? Okay. And knowing that Mr. Murphy comes around to every project at times, what what's your likely duration for the project? And then, if everything falls apart, how long do you figure that it'll take? Okay. And we're going to get into some more details here in just a little bit. Yeah. Now, if you've got all the time and money in the world, you can estimate. Huh, you can use the WBS to estimate from. Now, the you'll take estimates from the various teams or managers who have to deliver these components. Okay, and what you're doing is really a bottom up. Yeah, well, that's what it says. Bottom up estimate. So you take what your lowest level WBS components are and just keep estimating all the way up. Now this is something that can take an inordinate amount of time. If you have to come up with a best guess as for the duration or the amount of work that has to be done, this is probably not the way you're going to be able to go. Again, the obvious that this can only be used after the work breakdown structure has been well defined. Okay. Otherwise, you're introducing a lot of error into the estimates. All right. Some 3-point examples. Regular old triangular distribution or average. Formula is that the estimate is equal to the optimistic plus the most likely plus the pessimistic estimate divided by 3. Okay. So if your optimistic estimate is 3 weeks, you add 3 plus 5 plus 10 and divide by 3. And you come up with 6 weeks. Okay, 3 plus 5 plus 10 is equal to 18 divided by 3. Let's get into PERT average first, and then we'll come back up here. Formula for this is the estimate is equal to the optimistic plus 4 times the most likely plus pessimistic divided by 6. Okay. You always remember here, you've got 6 weights, a 1 here, a 4 here, and a 1 here. So you add those up. And that's what you divide by if you ever have a question like this.
Is that typically on a test?
Not too likely. Like I said, they've changed it a lot.
Yeah,
Back when I went
I was
through,
gonna say, oh,
Yeah.
go ahead.
I was just going to say back when I went through, yeah, you had to calculate all this stuff. But
Yeah, and having recently taken the test in July, that I did not see anything that required calculation of an equation.
yeah, this is mostly sort of you have a project. These are ways that you can do your estimates. Okay. One note here that PERT is based on probability distribution. Because of that, we can calculate a standard deviation, which is pessimistic minus optimistic, because pessimistic is always going to be greater, and divided by 6. Again, it's because we've got 6 weights in here. Okay. Critical path. In the old days, you had to calculate everything. You had to do a network diagram like this, precedence diagram, come up with everything in the that you could extract out of it. Do a forward pass, backwards pass, and everything else. But for critical path method, critical path is the longest duration path in a network diagram like this. Okay. So we've got 2 paths here and only 2 paths. First one, start with activity 1, activity 2, activity 4, and activity 6. Add up their durations, which are the numbers in the middle, and that's how many weeks it's going to take for the top path. That'd be 14 weeks. The other path, same thing. Add up activity 1, activity 3, activity 5, activity 6. And you're going to come up with 16 weeks. And since 16 is greater than 14, and you only have the 2 paths, the bottom one here is your critical path. And some of the characteristics of a critical path is that that is the minimum duration of your project. Unless things go wrong, your critical path is going to define how long it's going to take to deliver your project. You're not going to have to do a critical path on the test. But just in case you're really bored one day and you want to get into it, this key is going to screw you up like anything if you just look at it like it is. I can't affect these slides, but you need to stretch it out. Your duration is the number above each of these boxes. The early start date is the left component. The early finish date is the right component here. All right. Float is not shown on this whatsoever, so don't get confused by that. Left lower box is late start, how late you can start this activity. And the right one is the latest that you can finish it. Notice in this example, we've got multiple paths that we can take. We can go start to A, to C, to F, to N. We can go start to A, to D, to F, to end. You can go from start to A, to D, to E, to end. And we can also go start to B, to E, to end. Okay, so your critical path is going to be the one that is the greatest duration. Okay. In this case, it's going to be going from start to activity A, to activity D, to activity E, to end. Okay, if you take a look here, activity E, activity D are both 4. So that's 8 units of time. And activity A is 3 units of time. So your critical path is 11 units of time. I won't go through all the forward pass, backward pass stuff where you you determine what's called float, which is if a task or an activity is not on the critical path. Okay, you can never have any float whatsoever on the critical path. Float means that you can delay start or delay ending a task or activity. Okay, and still deliver the project on time. Okay. And this has been used for predictive projects for like ever. Wow. You can take a screenshot of this if you want. You can also go on the web and look up critical path, float, you know, the differences in floats, free float and total float, especially. But like I said, if you either can't sleep sometime or you're totally bored, you can look at it. They don't have it on the test anymore. But we had to, when I took the test, they would just give us a list of tasks, durations, and dependencies. And we'd have to construct the diagram, go through, determine the critical path, and do a forward pass like that, do a backwards pass to determine the amount of float in each of the paths. It was not the critical path. Oh. I'll tell you how old I am. All right, project schedule includes start and finish activities. Remember on those diagrams we showed start and finish? Sometimes start or finish has a number of activities in there and they need to be accounted for. We can extract project milestone dates out of the project schedule. Like whether or not we're going to be able to make a critical demonstration of the product, at a trade show or something like that. Okay, we can use the schedule to determine if it's highly probable, or we don't have it snowball's chance in Hades on that. You can also use it to track progress. You can have a project schedule for both predictive, it's where you're going to see the schedule mostly, and also for adaptive projects, because you can have the activities and then implement whatever is required for that activity to a cadence. So you can use adaptive methods within within a hybrid project. All right. There are a number of ways that you can present the schedule. These are just some of them. Either a roadmap, a Gantt chart, milestone chart, or a project schedule network diagram. All right. Anybody remember the name of the tool we used for scheduling activities in a project plan?
Schedule management plan.
Close. Close. We use precedence diagram method for scheduling activities in a project plan. Okay. Oh, all right, some examples. Let me see if that's the next slide. Okay. 22. All right. Usually on predictive projects, you're going to see a Gantt chart developed. That it's a way of envisioning when things can start, when things are estimated to be done, and in this case, you can show the number of tasks per day that these people are either signing up for or being signed up for. Okay. And any other of the resources. So this is definitely not a project in Chicago because it takes one heck of a lot longer than 2 days to obtain occupancy permits from the Chicago building department. That's for darn sure. Okay. But these are the activities and the durations. The diamonds represent milestones. In this case, it's complete landscaping and decoration. Has anyone not ever seen a Gantt chart before? I'll take the resounding crickets as you've all seen that.
Quick question though, when it says Karina A. Young, would she be the one responsible for the milestone, or is that just because I see that it's assigned? Go ahead.
It's should be responsible for achieving that milestone. Yes.
She would be responsible for that. Okay.
Yeah. And you know, when somebody is signing up for like 6 or 7 tasks a day, that's a lot of work. That's a lot of context switching. So be aware of that. Be careful with it too. Is there another question? All right. This is something that would probably be used for a management presentation. This is just a milestone chart or a milestone schedule. It just shows when things are going to be accomplished. Yeah. Okay, project schedule network diagram. This gives you an opportunity to visualize the interrelationships of the various activities. These notations in here are for this example only. Okay, so we're talking about some lag times in here, or lead. You can look at them as lead times at times. Okay, so straight relationship, finish to start. That's your the one that you're most often going to use. It also says here that activities B and C can start at the same time. Okay. Activities H and I can start, activity H can start, and then activity I can start 10 days later. Okay. Or 10 units of time later. Same thing for finish to start here. It means that when task or activity F finishes, activity G can start 15 days later.
So you couldn't
And
start that beforehand. You could not start that beforehand. It has to start 15 days after.
yeah,
Uh,
yeah, think of the example about the road. You've got to let the pillars, the concrete and the pillars cure before you can lay the road bed. Okay, makes sense?
all right. Yep.
Okay. And tasks L and J have a finish to finish relationship. They need to finish at the same time. You won't see notations like this except for excuse me, the lag times. If you're doing a project schedule network diagram, which you're probably not going to be asked to do. All right, a couple of ways to optimize the resources that you're going to need to complete the project. Smoothing means moving, putting resources to work at different activities other than the critical path. Okay, so what you're really doing is optimizing your use of people, you know, any physical types of equipment, right? Leveling, on the other hand, is balancing your supply and demand on resources, and it can affect your finish date. Okay, or you may need to adjust your start date. This can apply as the example I used before. If you've got some physical equipment like a particular crane that you need to use on 2 different buildings, how do you balance that between the two? Or, you know, if you require a certain person on the project and they've got limited availability, or they're over allocated, and you may need to adjust your start and finish dates to account for that. And leveling can change the critical path. If you want to get a screenshot. All right. A couple of different schedule compression techniques. One is fast tracking. Neither one of the fast tracking and crashing, neither one of these is guaranteed to work. Okay. Fast tracking means that you're going to try and do things in parallel and hope and pray that you don't have any mismatches. Like if you're building a railroad from the east and you're building one from the west, you know, you want to make sure that the right rails meet up. You know, the right one from the westbound and the left one from the eastbound had better made up. Otherwise, you got a lot of rework. It's going to cost you, and you know, your risk is really through the roof. Now, crashing is adding resources to an effort and seeing if you can pull the schedule in. Crashing only works on activities on the critical path and doesn't always produce a viable alternative. You know, you may be able to throw resources at everything and still not move that delivery date. Okay. And if you're putting additional resources on there, your costs are going to increase. There's a really good book on software development. It's by Fred Brooks, and the title is The Mythical Man Month. And it's one of the first times anything like this was talked about for software development. Okay, how adding additional people to a project that's already late is probably going to make it later. And you might be able to do it on some other types of projects, but don't count on it. I guess we got some deaths. All right, screenshots done. All right, for predictive projects, what you're going to do is create a baseline. This is once you've completed your planning activities, you have what's called a baseline. You include that in your project management plans. Yeah. Ideally, but not all the time, this happens before the project starts. So once you have a baseline established, you can then examine how the project is going throughout the lifetime of the project and see where your estimates were, you know, dead on or whether they were off. If there's any reason at all to change the baseline, any component of the baseline. With a predictive project, you do need to go through a CCB. Okay. Give you a second to take a screenshot. All right. All right. Special intervals. Anybody on the mobility side?
I'm here.
Yes.
Okay. What happens right around Mother's Day, Christmas, especially?
Firm up.
Actually, don't you have blackout days still, where you can't make any changes?
Yes.
Okay.
Yep,
CRP.
Yeah, like the
CRP.
iconic freeze.
the CRP or the iconic freezes.
Yeah. All right. So there are several things mentioned here. Now with the adaptive projects, PMI has what they call an iteration H or a hardening iteration or sprint. We'll go through this prior to the final release. Now, for the most advanced corporations that use adaptive methods, there is no such thing as an iteration H. There is no such thing as a blackout time. Okay. Example is Amazon. You know how they have Amazon days and all the days around Christmas? They're actually making more changes during those periods of time than normal. Okay, they're changing prices. They're putting in different ads. They're doing different ways of tracking what your purchasing history has been. Okay, so they don't have any blackout times at all, and they don't go through any hardening sprints. Each engineer who develops the software goes through the testing and is released to production whenever that engineer, that software developer decides it's ready. Okay. Now, in older industries, if you're trying to use adaptive methods, the hardening sprint may be something to take a look at. But for most agile efforts, the more sophisticated you are, the less likely you're going to use an iteration H. But know the term for the exam. We're not talking real world, we're talking what PMI has on the slides. Do you know what refactoring is? Can somebody give me a definition of refactoring? Okay, how about technical debt?
that's when you defer fixing code or fixing the defect.
I'm sorry, I didn't quite hear you. Could you repeat,
Um,
please?
That's when you defer or delay fixing a defect or,
Okay. Well, technical debt are things that you need to fix in the software. Okay, especially in software. Refactoring is where you improve the algorithms that you use to implement or deliver the value. Okay, because what you're doing with an adaptive or iterative process is that you're delivering things incrementally every 2 weeks. Okay, may not be the optimal way of implementing something, but you're able to deliver it. You're able to give the customer some value. You're able to get feedback from the customer. When you've got, before something becomes spaghetti code, what you want to do is have a backlog item that addresses refactoring or rewriting what the way that the value was implemented. Okay. And technical debt, excuse me, are addressing things that need to be fixed in the software itself, or the product itself, where things are not quite right. Okay. And they probably won't ask you about that anyway. Huh. Okay. Excuse me. Schedule management and adaptive environments. They give some guidelines. Schedule management is going to depend on team composition and life cycle. Okay. The project team and the product owner work together to decide what the schedule is going to be. The work together to develop the roadmap to show when releases are going to occur and what's going to be in each of the releases. Okay. The two different approaches is time boxed, where you're scheduling and working a backlog, and on demand for schedule if you have and it involves really continuous scheduling. Okay, this is more Scrum based. This is more Kanban based. Okay. All right. All right. Adaptive scheduling approaches. Comparing on demand with time box. So on demand, going to be Kanban or lean based. I'm going to let you read the slide. I'm kind of wearing down here. Need a second. One thing that you want to be aware of is that Kanban or lean based doesn't work well in projects where there are complex dependencies or relationships. One thing with time boxed or iterative, changes can be made at any time during the project. Ideally, changes are only made while at the end of an iteration. Okay? You don't want to go in and disrupt what the team is committed to. You don't want all right. You don't want to impose additional work on them, and just the whole idea, since everything is done in 2-week increments, that you're not really going to be waiting that long for a change. And if a change would result in something that doesn't need to be delivered within that sprint, then something else can be taken off the backlog to be implemented. All right. Team pulls work from a queue, whether it's time box or whether it's on demand. You can look at a queue as a backlog. Activities or in this case, user stories are in priority order in the backlog. All right. Adaptive planning. If you see here, if you're on a 2-week cadence, this is 2, 4, 6, 8, 10, usually go to iteration 5 or 6. So you're going to have each release take about 3 to 6 months. Okay, because it's going to take multiple iterations to create and deliver the value. What is done for each of the iterations, excuse me, is that a backlog is established. The stories are broken down, and they're assigned what they're called story points, okay, which is an indication of how much effort it's going to be to implement any particular task or really any user story. Velocity is really a measurement or an estimate of what a team can accomplish within a single sprint. What you want to do is, if you're an adaptive project, you continuously take a look at what was delivered in the past iterations. And we're not talking about the number of tasks. We're talking about the number of story points that are delivered. Yeah. And let's see what they say for velocity. Okay. Now, what's usually worked with are features for an adaptive effort. Okay. The features then get broken into user stories. Okay. Now, features need to support the product roadmap. And okay, for the organization. Story mapping is a concept that shows what stories can be completed in which iteration. Anybody give me a definition of what MVP is?
Minimum viable product.
Yep. Yep. Technically, an MVP is delivered one time only for an entire product's lifetime. Because an MVP is the minimum viable product that you can give to a customer, have them realize some value from it, and also give you feedback on it. Okay. MVP literally should be used to determine whether or not the product should be continued or whether it needs to be terminated. Okay. Now, in order to produce an MVP, it may take several iterations to do that. And that's what we're showing here are which user stories need to go into which iteration in order to result in a minimum viable product, and what can be deferred to later iterations. Okay. Questions on this? Okay. As I said, you don't want to measure the amount of time that it takes to do something. What you want to do is measure the effort that it takes to deliver value to the customer. Now, when we're estimating things, we can do just things like t-shirt sizing. Is this activity or this task extra small? Is it small, medium, large, extra large, extra large? In which case, if you're above a medium, you should be looking at breaking a story down into smaller stories. Okay. Anybody heard of story points before? And how about this? Anybody know what a Fibonacci sequence is?
Fibonacci sequence is used to basically rate the how much effort will be used to complete a user story based on other work that is aligned to it, kind of.
Okay.
Basically identify
Yeah.
difficulty level of what it is.
Yeah, what you're doing with the Fibonacci sequence is producing an estimate of how long of the effort to implement the story or the feature. Okay. Does anybody know what the Fibonacci sequence is? I mean, just no definition, just what the results are.
The numbers,
Yeah,
the 1, 3, 5, 8, and usually don't want it more than 8.
right. Yep, exactly. It Fibonacci sequence is the next number is determined by the sum of the previous two numbers. So generally a modified Fibonacci sequence is used because the true Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13. Okay. And you're absolutely right. If you get too high on the Fibonacci sequence, you better start thinking about breaking things down. Now, planning poker, I'm not sure if you're going to get any questions on this, but what it is everyone doing estimates has a deck of cards. They're a modified Fibonacci sequence. Okay. And as each of the stories or each of the features is brought up, those people who are doing the estimates determine, how they see it, how they see the size of the effort, okay, relative to a baseline, okay? Like a 1-day effort or a half-day effort. The thing is, the planning poker is a way of communicating. Each person picks a card that they feel represents the effort for that particular item, and when you say 5, 4, 3, 2, 1, you turn them over. So there are times where you may have someone who is new to the team who thinks an effort is either extremely high or extremely low. Okay. And what you want to do is ask questions about why a person feels that the planning poker estimate should be what they turned over. Okay, the factors that went into their decision. Okay. Teams learn a lot from planning poker. What can be done, what can't be done, or best guesses on what can be done. All right. Couple of things: definition of ready, definition of done. Definition of
What?
ready. Say again, please.
What? You want new AirPods? What are you talking about?
Oh,
You
okay,
want new AirPods?
okay.
How you want new AirPods?
Can you mute
you-
yourself if you're not discussing anything from the class? Appreciate it. A definition of ready is what constitutes the ability to start on an effort. Okay, it can include a checklist of things that have to occur before you can start work on it. For example, that you have to have an agreed to estimate of the magnitude of the works, say a user story. Okay, that you have to have if it requires particular resources, that all your resources are in line. Okay. All right. Definition of done means that there's nothing else to be done for that particular item. If it's a user story, it means that you have a checklist and everything on that checklist has been satisfied. Like everything has been tested, everything has been developed. Yeah. PMI says the definition of done is similar to acceptance criteria in a predictive project. All right. Each iteration, work from release backlog is moved into iteration or sprint backlog for that next 2-week effort. When you have multiple teams working on an effort, then the product managers work with each other too to determine what can be pulled from the release backlog for each of the teams. Okay, sprint planning is done upfront, totally upfront. First thing that happens for an iteration. Now, at the end, you're going to do a retrospective. You're going to take the feedback from the customers, feedback from the team, and you know, especially if some of the estimates were not optimized and you learned things along the way in trying to implement them, can affect what the prioritization is for the completion of that effort. Okay. Let's grab the so what they mean here at the bottom, the work does not carry over to the next iteration. You don't just continue working on something. Product owner reevaluates the priority of that effort against everything else in the backlog. Okay, and prioritizes it. So literally, if you find that the estimate said that it should be like a small effort and turns into an extra large, well, you don't just continue with it. You take a look at it, you work with any of the stakeholders and see where it fits in with the rest of the work that has to be done. Okay, so you can work on something for 2 weeks, and then if you haven't finished it, if it still has a lot of work to be done on it, you may not finish it ever. It may not be a high enough priority. Okay. All right.
If it is completely different when what was expected or minute changes.
If you haven't completed it, it needs to be reprioritized against everything else in the backlog. It could be minor changes that need to be done. Could be major changes that need to be done. It really depends on the priority of what needs to be delivered. Okay. So does that address it? Address your question?
Yes, it does.
Okay. So I think the last thing we're going to be talking about tonight is hybrid scheduling models. So as we alluded to before, a hybrid project includes both aspects of predictive projects and adaptive projects. Okay. So in this case, the project manager plans a high-level project phases and milestones, and then the Scrum Master and the product owner work to run sprints that deliver incremental value along the product lifetime. Huh. All right, we're going to get through this. So project manager is going to identify the project work types and then try to break them down. Okay. The team is not involved with that. They will just implement what's in the backlog. Project manager is also going to create a prioritized work backlog, which is used to deliver the right amount of value for each of the project phases and achieves the milestones that have been set up. Milestone, again, being something like taking the product to a trade show. Now, going to be the hybrid project is going to be working in iterations or sprints. Okay. Ideally, a sprint's going to be 2 weeks. The team itself is going to plan work before every iteration using prioritized backlog items. That's where your product owner comes in. Estimate every task or story to decide how many can fit into a single sprint. Okay, this is where velocity comes in. Velocity is the historic amount of work that the team can deliver. Okay, and you use that along with the estimates for each of the tasks that have to be accomplished. Okay, so you don't want to overcommit, you don't want to undercommit. And then hold a retrospective at the end of each sprint. Okay. And things that can occur there are capturing the metrics to adjust any of the timing and task estimates for the next sprint. Okay. All right, we made it through it. All right. And if you notice, we only covered about 3 sections of the ECO. So this stuff, you need to know it. You're not going to be asked any questions on how to do any formulas, but you will need to know the concepts because the questions will revolve around these concepts. All right. About 2.5 minutes. I'll stick around if you want, if there are any questions about tonight. Must be stomachs are rumbling.
Among other things.
Just soaking it in.
Okay. All right. Alan, can you stop the recording, please?
Yes, sir.
Thank you. And we'll talk to you guys again on Wednesday.